in the original relation number 1, should be maintained in relation number 2 and relation number 3. Means whatever dependency, functional dependency we have in relation number 2, along with the dependency we have in relation number 3, those dependencies should be there also in relation number 1. Okay, so for example, in relation number 1, I'll just write it here. So we have R1. After decomposing, we got R2 and R3. Okay, so R1 is the original relation. We found this relation to be not in the proper normal form. In a particular normal form, it is not in this particular normal form. Then we are going to decompose it into R2 and R3 in order to bring it to the normal form that we want. Okay, so this process of decomposing R1 to R2 and R3 in order to bring to a particular normal form is known as normalization. Okay, so this R1 and R2 should preserve two properties. One is lossless join and another one is dependency preservation. So the first one, that is lossless join, this lossless join specifies that when we perform join to R2 and R3, the resultant should be R1. Okay, so if this particular property is preserved, then it is known as a lossless join property, and it preserves the lossless join property. Okay, another property is dependency preservation. So if we have 3 functional dependency in R1, say functional dependency number 1, functional dependency number 1, functional dependency number 2, and functional dependency number 3. F1, F2, F3 are there in R1. Okay, then this F1, F2, F3, it should be in R2 and R3. Means in R2 we might found functional dependency number F2. Okay, in R3 we might found functional dependency F2 and F3, like that. Okay, so the whatever functional dependency we have in R1 should be preserved in this R2 and R3 also. Okay, so the combination of functional dependency that we have in R2 and R3 is the same functional dependency, should be the same functional dependency we have in R1. Okay, so these two properties should be preserved whenever we perform the decomposition, or you can say whenever we perform the normalization. So this is your normalization. This is some basic things about normalization. Okay. So some more things that you need to know about normalization before starting normalization is some few terms. Let us see those terms one by one. The first one is prime and non-prime attributes. So you need to know what is a prime attribute and what is a non-prime attribute. So prime attributes, member of key is a prime attribute. Key may be made up of many attributes, isn't it? So if a particular attribute is a member of a key, then those attributes are known as prime attributes. Okay. So the other remaining attributes which are not a part of a key is known as non-prime attributes. Okay. Another thing is full functional dependency. What is this full functional dependency? If there is a functional dependency, X determines Y. If removal of any attribute A from X means that the dependency does not hold anymore, then X determines Y is full functional dependency. Okay. Otherwise, it is a partial functional dependency. Okay. So here X is also a set of, here X represents a set of attributes and Y also represents a set of attributes, isn't it? So Y should be fully functionally dependent on all the attributes that is there in X. Okay, it should not be depending on only some few attributes that is in X. Okay, so if it is fully depending on X, means fully depending on all the attribute of X, then it is known as full functional dependency. Okay. Otherwise, they are partial functional dependency. So remember this term. The last one is transitive dependency. So what is this transitive dependency? We have a functional dependency as determined Y. Okay. It's transitive if there is a set of non-prime attributes. If there is a set of non-prime attributes, Z. Okay. And X determines Z, Z determines Y holds. Then this functional dependency is a transitive dependency. That means if there is a set of attributes in the middle between this X and Y is depending on X because of this Z, then it is known as a transitive dependency. Okay. Now let us see the normal forms one by one. So in order to perform normalization again, you are going to check the whether the relation is in normal forms with in a particular normal form or not, isn't it? So for that you need to know what is this normal form. There are some few normal forms like first normal form, second normal form, third normal form, BCNS, and then we have fourth normal form, fifth normal form. So some of the most important, we will just discuss the most important things like first normal form, and then we will see second normal form, and then, am I audible?
Yes, ma'am.
Okay. So we'll see first normal form, and then we'll see second normal form, third normal form. After that, we'll see BCNF. Fourth normal form, fifth normal form, they are not that important. They are not that required. So we'll skip those things. Let us see the first one, that is first normal form. So it says that the domain of an attribute must include only atomic values, and the value in a tuple must be a single value from the domain of that attribute. So it means it should be atomic, and also it should be a single value. You can't have a composite attribute, a complex attribute, or you cannot have multi-valued attributes. Okay, it should be atomic, means it's the value that you have to put in that particular attribute should be atomic. Okay, and it should have only a single value. So here, if this particular property is satisfied, then we can say that the relation is in first normal form. Okay. So here we know that this is a department relation. So in the department relation, the location was a multi-valued attribute, isn't it? So this is some knowledge that we already have. So that is why I'm taking this as an example. But the location was a multi-valued. So if your design, if you do your design in such a way, in this way, then what will happen is the location was a multi-valued attribute. It's a multi-valued attribute. So this particular relation is not in first normal form. Okay, this particular relation is not in first normal form. So in order to bring it into first normal form, you need to perform the normalization. Okay, that means we are going to perform a decomposition. So how we are going to normalize or decompose it? We are going to use the concept of functional dependency in order to normalize or decompose. Okay, so the functional, we have only a single functional dependency here. D number can determine D name, D MGRSSN, and also D location. Okay, so this is the only functional dependency we have here. So by using this functional dependency, what will happen is we will separate this D location from this particular relation. Why? Because D location is the one which is a multi-valued attribute, isn't it? So we will separate it from this relation, and we will separately have a relation containing this D location along with the attribute by using which means that along with the attribute which is functionally depending by this D location. Okay, so that is why we have two relations after normalization, this relation and this relation. So in this relation, this is the, you can say this is the original relation. after removing D location. So means after removing D location, you will have D name, D number, and DMGR SSN, isn't it? So this is that particular relation, and we have removed this D location, and we will make a separate relation containing the D location along with the attribute to which the D location is depending, functionally depending. Okay, and that is D number, isn't it? So that is why we have D number and D location in the another relation. So we have smaller, means we have decomposed the bigger relation into two smaller relations by using the process of normalization. And we bring it into first normal form. So this is also in first normal form, this is also in first normal form. Okay, so D number, according to this D number, you can have many tuples. Okay, but here you can't, means it, as it has many other attributes, you can't have multiple tuples. Okay, and you can see here the key also changes. Key is going to be D number along with this D location. Combination of these two is going to be the key. Here the key was only D number. Now, do this particular normalization preserve the two properties that I told you? The first one is loose/join. So when you join these two relation, you are going to get this one. Okay, so the first property is preserved. What about the second property? There was only a single functional dependency where D name and DMGR and D location were depending on D number, isn't it? So here you can also see D name and DMGR is still depending on D number. And again, when you see some few, means when you are going to get some few, some few values, you will, means when you have some few values for D number, you are going to get some few values of D locations also, isn't it? At that point of time, again, D location will also depend on D number, but means there is going to be multiple values of those things, and these two are going to be the key. Okay, so these two are going to be key. So as it is a multi-valued attribute, the values, whatever values it is going to have, still depends on D number. Okay, so the functional dependency, dependency preservation property is also maintained. Okay, so that is first normal form. The second one, this first normal form, it is if we properly design the ER model, and when you convert the ER model to relational model, we know that we can't just put the attributes which is composite and also multi-valued as it is, isn't it? We have to either decompose it if it is a composite attribute, and if it is a multi-valued, then we have to have a separate relation for it, isn't it? So if you do a proper designing there, then you are not going to face this particular normalization. The second one is second normal form. So a relation R is in second normal form if it is in first normal form. Okay, if it is in first normal form, it should be in first normal form, and also non-prime attributes. Any non-prime attribute A in R fully functionally dependent on the primary key of R. Okay, all the non-prime attributes that we have in the relation should be fully functionally dependent on the primary key, on the key attribute. Okay, it should not, there shouldn't be any partial dependency between the non-prime attribute and the key. Okay, all the non-prime attributes should be fully functionally dependent. So there shouldn't be any partial functional dependency. So if there is no partial functional dependency, then we can say that the particular relation is in second normal form. Okay, so here an example is given: SSN, P number, Rs, E name, P location. So Rs depend on SSN, both SSN and P number. And here the primary key is the combination of SSN and P number. Okay, the combination of SSN and P number is going to be the key. ename depend only on SSN. It does not depend on P number. Pname, there is a project name, depends on P number. It does not depend on SSN. Okay, and P location depends on P number, not in this SSN. So that means there is some partial functional dependency here, isn't it? R's fully depend on the key, but ename partially depend on the key, isn't it? Because it depends only on SSN. So that is why it is partial functional dependency. Pname, P location also partially depends on the key because it does not depend on SSN. It only depends on P number. Okay, so that means this particular relation, a given relation, is not in second normal form. So if you want to bring it in the second normal form, then what we will do is, we are assuming that all the attributes are atomic and single value. Okay, so it is already in first normal form. So we are about to make all the attributes, non-prime attributes, fully functionally dependent on the primary key. So we need to decompose it. Okay, according to this functional dependency again. So whatever fully functionally dependent we have, we will make it like, means we are not going to do anything on that because ours is fully functionally dependent on SSN and P number, isn't it? So we do not need to do anything for ours. What we need to do is, what we need to change is in the partial dependency, that is in with this ename, pname, and p location. So for the partial dependency, again, we need to see in which part of the key it is depending. Okay, so ename is depending on SSN, isn't it? Pname, p location is depending on p number. That means by using this particular partial dependency, we can make it. Wait a second. Okay. So yeah. So partial, there is this two partial dependency, isn't it? So according to this two partial dependency, for this two partial dependency, we will create two different relations. Okay. The first relation will contain the partial means the ename, which is means the attribute which is partially depending on the key, along with the attribute in which to which this particular attribute is depending. Okay, same thing again here also for the second partial dependency, we will take out this pname and p location, and we will have another attribute which is the attribute part of the key which is to which the pname and p location is depending. So this we already have, means from the relation we have taken out this ename, pname, and p location, isn't it? So the remaining things are SSN, p number, R. So we have this one. The second one is ename along with SSN, and then pname, p number along with the prime attribute to which they were depending. Okay, so we'll decompose them into these three smaller relations. Okay, again same thing, all the things are going to be, means it is going to have the lossless join, means when you join these three relations you are going to get this one, and then the dependencies are also preserving. Okay, p number, R's depending on R's is depending on p number and SSN, and ename is depending on SSN, and pname and p location is depending on p number. So the combination of the functional dependency for these three smaller relations is the functional dependency that we have in this original given relation. Okay, and you can see that this is in second normal form, this is also in second normal form, this is also in second normal form. That means there is no partial dependence. So this is second normal form. Third normal form. A relation R is in third normal form if it is in second normal form and no non-prime attribute of R transitively dependent on the primary key. So if there is non-prime attribute, then non-prime attribute should not be transitively depending on the primary key. Okay, like here in this example, you can see that Dname and Dmgr SSN is transitively depending on the primary key SSN. Here SSN is a primary key. Okay. So we are just taking an example here. You can take any example. So the SSN is a primary key. Dname, that is department name, and department MGR SSN is depending on D number. And D number is again depending on SSN. So like that, Dname and Dmgr SSN, these are non-prime attributes, isn't it? So these non-prime attributes are transitively depending on the primary key. Okay. If something like this is there, then we can say that it is not in third normal form. It is not in third normal form. So in order to bring it into third normal form, so it should be in second normal form. So you can see that they are all in. There is no partial dependency. They are all fully functionally depending on SSN, whether it is transitively or whether it is directly. They are fully functionally dependent on SSN. So it is in the second normal form. It is already in second normal form. Okay. Now, in order to bring it into third normal form, we will decompose it again using the functional dependency. Okay. So same thing. Whatever transitively depending, we will remove. Whatever attribute that is transitively depending on the primary key, we will remove along with the attribute to which they are depending. And this attribute will become the primary key in this particular newly created relation. Okay, and this is the original relation from which these are removed. Okay, so lossless join is also preserved, and then the dependency preserving this one, or is also property is also preserved. So this is going to be the last normal form, BCNF. So after, if your relation is in first normal form, okay, most of the relation is going to be in first normal form. So first normal form is not that required. It means all the attributes are going to be atomic or and single value. So if after having a first normal form relation, you can directly apply this BCNF. Okay, instead of applying second normal form and third normal form, you can directly apply BCNF, because whatever definition is given, means whatever rule that is given for this BCNF, if it is satisfied, then it is automatically going to satisfy the property of second normal form and also the property of third normal form. Okay, so let us read this out. A relation R is in BCNF if whenever a non-trivial functional dependency X determining Y holds in R, then X is a key of R. Okay, if there is any functional dependency X determining Y in R, then this X should be the key. Okay, for sure this X should be the key. Okay, and there shouldn't be any partial dependency. Means it should be depending, the Y should be depending on the whole X. Okay, so this is BCNF. Now here you can see A is the key. We have other non-prime attributes B, C, and D. So here you can see B, C, D is depending on the key A. Okay, but there is another dependency, functional dependency, that is B can be determined from D, means B is depending on D, and D is not the key, isn't it? So this particular property that is defined here for the BCNF is not satisfied because of the second functional dependency. Okay, so because of this second functional dependency, we are going to decompose it. Okay, same thing again. The attribute means this according to this functional dependency, we are going to decompose. We are going to decompose it like this. So this particular attribute D and B, you can see this B. This B is the attribute which is which is depending on another attribute which is not a key, isn't it? So this is the particular attribute which is this one, not maintaining the property of BCNF. Okay, so which is means it is because of this we are having the problem. So that is why we will remove this B. Okay, we remove this B along with the attribute which is depending by this B. So we will have another relation, a smaller relation, B containing only B and B. And here D is going to be the key. Okay, so the remaining attributes are going, means the remaining attribute which remains on this original relation is going to be A, C and D. Okay, so that is why we have A, C, D here. A will still be going to be the key. So this is the decomposition process that we have to do according to BCNF. Okay, so if there is any functional dependency, non-trivial functional dependency in the relation, and we are going to say that it is in a BCNF only if all the functional dependency X determine Y has the property X is the key. Okay, means X must be a key. Okay, and Y should be depending on the whole X. So any doubt? So for this normalization, the question maybe comes like this. So there will be a relational schema or a relation will be given to you. You might be asked in which normal form the particular relation is in. And after that, you might be asked to bring it to a third normal form or either third normal form or either second normal form or BCNF, like that. Okay, so this is a very common question. Some few common question on normalization. Anything you want to ask? We have done functional dependency and normalization. So we'll start a new chapter from the next class. Any doubt? Okay, then let me take your attendance. Enrollment number 1.
Present, ma'am.